Okay, so let us now talk about peak to peak value, RMS value, and average value. So, what does it mean to have peak to peak? You have a signal that's alternating, and at any given point, it reaches a maximum and a minimum. The difference between the two is called your peak to peak. So, this is V peak to peak, VPP. So, V peak to peak is equal to the difference between your maximum and your minimum divided by 2. And that's basically what peak to peak is. Now, sometimes this encodes something specific about the signal. It either gives you some high readings or low readings. The example that comes to mind is the concept of biomedical recordings. So, biomedical recordings are encoded in terms of sensors. Sensors encode voltage. Voltage you have to decode to give you something useful. Let's say you're reading a blood pressure. Let's say you're reading a blood pressure signal, and then it looks something like this. This might reach, just to give some maybe unrealistic numbers. Let's say this might reach 20 millivolts. Just to give some unrealistic numbers for, but this maybe encodes that you have, I don't know, let's say you compressed it to 170 just when you're using the old analog methods. And then maybe along the way, this curve right here, as you're kind of scoping into it, you can actually look at a few things about it. But just in general, let's say that 20 millivolts is your peak. Now, and then what that encodes to you is maybe you have a compression of 170, let's say, pounds per square inch, psi. A bit unrealistic, uh, very dangerous actually. But let's say, in theory, hypothetically, this was the case. Then what this is telling you is something useful. It's telling you, oh, you put 170 pounds per square inch maximum on yourself. And then maybe at some point it dips to 0. So if you take the difference between the two, your peak to peak voltage is just going to be, well, 20 millivolts minus 0 millivolts divided by 2, giving you 10 millivolts. That's just one example. Of course, don't if you see 170 pounds per square inch applied onto your arm, just know you are it. Okay, now let's talk about RMS voltage and average value. Let's first talk about RMS. What does it mean to have RMS? RMS stands for roots mean squared. It tells you a signal squared encoded as the following. Squared, VT. Now, for the case of an alternating signal, one that is sinusoidal in nature, let's say, this relationship VRMS is equal to V of t divided by the square root of 2. So mean, you have the root mean and then squared part of it. Now, why would this be useful? Well, usually looking at averages aren't always helpful because if it's a sinusoidal, the average of a sinusoidal doesn't tell us anything, because if we take the average of this region and then the average of this region, that equates to a zero sum region. So it doesn't tell us anything. And if you wanted to tell us something, and if you wanted it to tell us something, then you won't be able to. Whereas for root mean squares, usually they give you about this much room, and this much room will encode a lot of information, and perhaps you can relay it to, say, your manager and say, oh, maybe 170 pounds per square inch is not a good idea. Let's go for something lower, like, I don't know, um, 10 psi. Maybe a little too little, but maybe it's like, oh, that's okay. That's a realistic number. So this would then be your RMS value. So so this is how we calculate RMS. Now, if you're given RMS and you wanted to convert it to maximum voltage, well, looking at this relationship, V of t is just equal to V RMS square root of 2. Now, just to preface this, in mathematics, I would always put term before the square root, because when you're punching it into your calculator, and this is just important advice, it's important not to go square root first, because you might accidentally punch in the quantity inside. While mathematically it doesn't matter, you have to just be careful of that. Okay, now, similar to RMS, we have average value. And I actually should have talked about average values first. But average value, as the name implies, it's just the sum of terms, like so. Now, what ends up happening is that if you have a sinusoidal signal, so in the case of sinusoidal, or even or just alternating signals in general, V average is always going to be 0. If you have the case of a maybe signal that isn't alternating, like a DC source, then you might be able to tell and give some information about it. So maybe you're reading something within an ECG. Here's the setup. So this is you smiling on the inside. And then there's a few things we have to encode. Here's your ground. Here's your positive reading. And then here's your negative reading. Whoops. Now, within this information, you can probably get some idea about it, and you read, let's say, 1,000 samples within 60 seconds. So your V average is going to tell you, oh, maybe you've read, I don't know, let's give an unrealistic number again, 50 millivolts average. And then you read that 50 millivolts average corresponded to 70 beats per minute. Okay, that's okay. That's a normal reading. Maybe for somebody else, they might read 90 beats per minute. Not bad either. Maybe it might read 150 beats per minute, but you're relaxed, and that should be a concern. So, in summary, though, peak to peak voltage just means comparing maximum and minimum. Root mean square means comparing the roots, or comparing the square of the mean root, which is right here. just by kind of just truncating a portion of it and just getting some value information out of this. Well, average gives us something like this. You can actually use this formula as well because this is just the definition of average. Okay? All right. Thank you.